Good afternoon. Initially, I wish you all and happy Engineers Day for the upcoming engineers. And I would like to deal with respect to hydraulic actuators contribution in the mechatronics subject, particularly in the today's class. Hydraulic actuators, as have been discussed, the main difference between this hydraulic and pneumatic, and what are the actuators, different types, and these type of actuators utilized in an industrial fields or in a wide applications. Most probably we'll be recalling the basic difference between this hydraulic and pneumatic once again, and in this class starting from the actuators. Basically, these hydraulic systems used to control and transmit the power from one place to another place within pressurized conditions, and indeed to impart a particular pressure, the motor acts as an prime mover which creates the pressure to the fluid, and the directional control valves specifies to move these pressurized fluids as per the channel that the actuation should be considered in a particular mode of direction, that either it may be of moving in extension stroke or forward stroke or contraction stroke, that is an return stroke. As per the output constraint, that cylinder and piston arrangement is being positioned, and the activity of this pressurization with respect to the utilization of the prime mover, that is motor, and drives with respect to the equipments or directional control valves. So without any doubt, we can definitely say in the case of these hydraulic systems that an actuator is used to convert the energy of a fluid back into the mechanical power. Here, the output power which is developed, that is depending upon the flow rate, pressure drop across the actuators, and its overall efficiency. And hence these are the devices used to convert the pressure energy to the fluid. Pressure energy which is created by the help of this prime mover, that is motor, within the fluid into the mechanical actions. That is nothing but the movement of these actuators, either in a linear kind of movements or rotary movements, and the vice versa, that is both in clockwise and counterclockwise directions. And simultaneously different types of actuation criteria are followed with respect to these actuators, not only considering these linear and rotary. Additionally, this semi-rotary actuators, which is having only in one direction of movement. There is also in the case of only particular sequence of steps. Hence, it leads to the different types of actuations. That is depending upon the different types of actuations. So first one, it is a linear actuator. It will be acting only in the movement of only one coordinate axis, which is having two different signatures. That is either positive x or minus x, or it says a positive y or negative y. and simultaneously either positive Z or negative Z. Considering in the case of rotatory actuator, the hydraulic motor would specifies or having an rotatory both in clockwise with the polarities changes and counterclockwise as well. And moving to the another type, that is a semi-rotary actuator. It is for limited to an angle of actuation. That is semi-rotatory actuators. Coming to the point of this hydraulic linear actuators, how the name is implies and what is the basic phenomena regarding it, will be looking after. So they are referred to in cylinders, rams, cams, and jacks, whose the total movement is determined by construction of with respect to the above units. And the major function of these hydraulic cylinder is to convert the power that has been generated from the hydraulic source, that is pressurized fluid, to an linear mechanical forces or any kind of motions, as we have been discussed in the types of actuation systems. And moving on to the hydraulic cylinder extension, and these hydraulic cylinder extends and retracts the piston rod, which causes the pull or push force towards the external load along the straight path, as you have been visualized in the case of this cylinder and piston arrangement. As the fluid enters into the input port 1, and output port or port number 2 will be retracts back the already entered fluid back to the reservoir, as this we have been seen in the yesterday's class. And vice versa, the directional control valve specifies the reverse motion, that is entering of this pressurized fluid towards the channel number 2 leads to the reverse flow at the port number 1. And from that port number 1, already entered fluids, when the forward stroke is being taking place, will be returned back or drained back to the reservoir again. And coming to the hydraulic cylinders, cylinder and piston arrangements. So, how many types of actions that are made that are yet to be progressed? So, initially, we're having single acting cylinders, double acting cylinders, telescopic cylinders, and tandem cylinders. So, in the previous sessions, we have been seeing within basic cylinder and piston arrangement, and how does it works based upon the pressurized fluids or else pressurized or compressed air or gaseous medium. We'll be looking after the each and every component. Here in the single acting cylinder, there will be only one movement which is energized with respect to the pressurized, either pressurized fluid or gaseous medium. And coming to the point that only in the case of this hydraulic system, we'll be utilizing only the pressurized fluid, right? That fluid may be of different kinds of oils which are having it, which is varied at different viscosity levels. And the movement here, single acting cylinder, refers to the arrangement as shown in the diagram, that from this port 1, the pressurized fluid will be entering into the cylinder, and hence that pressurized cylinder will tends to move or cope up with respect to the tension existing in the spring that is has been attached here within the within the piston and to the top dead center of this particular cylinder. And when until the equilibrium strategy of the fluid within pressurized condition enters into the cylinder, the tension that is existing within the spring that has been structured away will stop the or oppose the entry of that particular fluid. So if the tension of this particular spring has been crossed over by the pressure conditions that are maintaining to the fluid in the hydraulic case, then automatically definitely the pressure which is entering is very much high when compared to the tension, and the compression will be starting within the spring, and it leads to the extension of this particular cylinder piston, and the compression will be taking place within the spring. And next, the tension that is up to the capable range will be compressed in such a case, and at that particular position a vent port is being created, that a vacuum that is being entering already existing within this particular region will be led towards the atmosphere. If at all any fluid has been filled out at this particular section, those will be drained to the particular oil cylinder, oil reservoir. And when the additional pressure that is being maintained indeed to move the piston towards the forward stroke or extension stroke, that in such a way that pressure if has been halted or reduced or maintained with respect to equating of this tension in the spring causes in the spring, or else less than the tension existing within the spring, simultaneously the movement towards the forward will be getting stopped. And when there is a complete extension within the forward stroke has been commenced, I think we will be observing the full spring tension existing here. And if the pressure has been cut off at this particular range, and simultaneously this fluid which is entered here have to be drained towards the reservoir back again due to loss of pressure, and the prime mover will be getting switched off in condition, and the pressure which is maintained till in the forward stroke will be getting decreased due to the high tension created in the spring, and it leads to create a back movement as per the Newton's third law with the same force which is has been entered in forward direction. So, as per the Newton's third law, it tends to or opposes the force that is being existing within that particular stored in that particular spring towards the back again, and that piston will return back to the major position, that is top dead center to the bottom dead center, or else towards the forward stroke to return stroke again without any external support, because in the forward stroke the pressure that has been entering from this port 1 in the form of a fluid which creates the high amount of tension which is unbearable or maximum bearable or ultimate tensile position in the case of this spring. So which is having high amount of energy that has been stored here will tense if the pressure here in the input level has been cut off. So as per the Newton's third law, we are having that similar and same force with an back movement will be created, and it will be tending towards the original position back again. So this is the theoretical position or theoretical attachment given here based upon the single acting cylinder consists of a piston attachment of the rod. At one end it is attached, and the another end the spring has been calculated, and depending upon the force that has been entered, the same just we have been discussed will be relating here. Hydraulic pressure acting on the piston, and tightening of the spring is not done hydraulically because the pressurized fluid we are not utilizing in the backward movement, because the tension which is created due to the pressurized fluid in the forward direction creates the back movement when the continuous supply at the input has been stopped. Coming to the point of this double acting cylinder, in the double acting cylinder we are having two different types. First one is piston rod on one side and on the both sides. We'll be having in detail regarding these two sections in the case of double acting cylinder. Alright, so double acting cylinder, this one diagram. When pump with pressurized condition flows towards this port 1, considering this is an inlet port 1 and this is an inlet port 2. And from this, the prime mover, as we have been discussed, will create the high pressure than the atmospheric range. That is a normal atmospheric range. The pressure in the normal atmospheric range is on 1 atmosphere and it creates 1 bar of pressure. And generally, by the utilization of this motor, it creates higher highest pressure than the existing pressure at here. When the pressurized fluid enters into the port 1, the port 2 will be connected to the oil reservoir and the forward stroke will be getting commenced. And in the case of return stroke, the directional control valve deviates the connections to the port 1 to port 2 and port 2 to port 1. And hence this pressurized fluid which is creating by the prime mover will enters into the port 2 and creates the backward movement simultaneously. That is here, pump flow will be connected to here and backward movement will be commencing. And return flow is drained the fluid back to the oil reservoir. And this is the piston seal which is moving towards the forward direction simultaneously towards the backward direction. The double acting cylinder piston rod at one sided, it is to extend the cylinder and the pump flow is sent back blank in the port as you have been seen in the diagram. The fluid from the rod and port returns to the reservoir. That also we have been seen that the return fluid will be again drained towards the oil reservoir and hence the retraction stroke will be taken place. And in the case of this double acting or double tending rods on both sides, so piston commences two different actions simultaneously. So here at the end of this rod, one of the external support will be connected and here too as well the another support will be getting connected. And while moving towards the forward direction, for this left side piston it will be acting as a contraction and towards the right side it will be acting as a forward stroke. And simultaneously in the case of backward movement, there is a left side movement, the piston which is tends towards the right side direction will be acting as an return stroke and this creates left side creates the extension stroke. Simultaneously two different tasks can be commenced simultaneously in the case of this piston rod on both the sides. And rest of the operations with respect to the pressurized fluid enters the port 1 and left back and drained at the port 2. And simultaneously at the port 2 if it has been enters and simultaneously from the port 1 it will be draining back to the oil reservoir. So this double acting cylinder piston on the both sides leads to an, such kind of actions. Coming to the point of this telescoping cylinder, this is the main concept of this telescoping cylinder having stages, different stages with the pressure port. This needs a long stroke length because the extensions should be increased only one side direction unless of the rods at both the ends. So after getting extended up to the one cylindrical range, then continuously the submerged cylinders will be again furtherly extending to a maximum that the design criteria has been done. So for example, this is stage 1, stage 2. This hook will be getting inserted to the stage 3, and again hook and the stage 3 which is containing will be inserted to the stage 2. That means entire the stage 3 is existing in the stage 2. And when the construction position stage 2 is again merged to the stage 1, and that is nothing but the stage 1 is consisting of stage 2 and 3. And if on and these three stages has been compressed here, if there is extension, it will be occupying this. Or if this is in contraction position, it will be seems like this. Thus occupying the less space for volumetric conditions and commencing of a majority of the activity. So here activity refers to the extension up to a maximum length levels. So here only three stages has been considered. Meanwhile, depending upon the strategy, if further length need to be compensated, it can be extended as well. Coming to the point of this, the telescopic cylinder, it's having a multi-level ports which is connected from one dynamic region to the another, one output of cylinder and piston arrangement to the another input. One output will be entering connected directly to the second cylinder input. So vice versa. So here connection generally consists of nested tubes and operate on the displacement principle. These tubes are supported by bearing rings, innermost set of which have grooves and channels to allow the fluid flow. And you can stop the rings limit movement at each and every section, and thus it prevents the separation also as well. There's a tandem cylinder which is having the criteria that when the fluid being entering into the port number 1, the forward movement will be taking place by the cylinder, and simultaneously if there is any necessity of additional weight generation, simultaneously to the port 1 to port 3 the fluid will be getting enters and tends to move towards the forward stroke. Vice versa, if the return stroke need to be commenced within loading conditions, then port 3 and port 4 and port 2 has to be get inputted in the case of pressurized fuel. There is a tandem cylinder. The major application of this tandem cylinder is large amount of force is required to be applied for small diameter cylinders. So that is a major application, and they used to move the loading conditions, loading, very much loading in load situations. That is nothing but in the lift carriers, weight lifts from one altitude to the very high altitudes, etc. plays a major role. Even this is having a main drawback that cylinders must have together a standard cylinder to achieve an equal speed. If there is any alternate material that has been utilized for both the pistons and cylinder arrangement in the connectivity, then the accuracy may not be achieved that the standard cylinder is maintaining will not be leads to move to by the secondary aspect of cylinder. We'll be having some of the graphical representations in the case of this cylinder and piston actuators. First one, it is single acting cylinder with unspecified return. So hence here unspecified clearly indicating that the pressurized fluid will be entering into the input for the forward stroke movement at this port 1. There is no any another port, and hence the pressurized fluid will be remains constant even at the extension position of this piston. and the external force which is required manually applied on that particular piston to drain the fluid which has been entered into the cylinder. So else, not only manually, even in an automated or semi-automated conditions, externally the force need to be applied indeed to correct contracting position in the case of single acting cylinder with unspecified, also unspecified in the sense you don't know when it will be applied. Based upon the necessary or needy conditions, then the action will be getting progressed. Coming to the point of the single acting cylinder with spring return, just we have been seen in our class. And even double acting cylinder with single piston rod, we have been verified. And double acting cylinder with double piston rod, which is a symbolic representation, simultaneously both the actions. Either we have been considered this right side forward direction, simultaneously for this left side case of cylinder, we will be considering as in return stroke. And if there is any return stroke for this particular right side cylinder, the extension stroke will be converging towards the left side cylinder. So this is the action that is being performed within multi characterizations. And furtherly, this telescopic cylinder, which will be having an emerging concept upon extinction and contraction. The fluid which is entering just relieves of towards the output. And telescoping conditions, which will be having extinction and contraction, will be based upon the de dismantle or de-energize of the fluid pressure which is energizing in the extension stroke. So double acting cylinder which an fixed cushion on one side, simultaneously the variable cushion on one side which can be varied, and double acting cylinder with an cushioning on both the sides, variable with an variable strategy. So cushioning. So what is meant by cushioning? Absorb, absorbing of some of the pressure and arresting it to a particular extent without causing any of the damage to the major components within the body of an control system is called this cushioning. We can clearly specify our shock absorbers in the case of automobiles, not even in the four wheelers or two wheelers or n number of wheels that we will be utilizing. So maximum pressure, the overall body weight of that particular automobile is being fall on these shock absorbers, which creates a lot tension and releases towards the atmosphere upon cushioning. So this adjusts the restrictors. And here the hydraulic plays a major important role indeed to oppose the maximum load that is even falling on that particular cylinder piston arrangement, which is having created with respect to a particular tension existing by a viscous plate. So what plays a major prevention? Listen, prevention of shock due to the stopping loads. Just we have been discussed as per the case of these shock absorbers, and these cushion devices are very much widely used or applied at either end or both the ends. Obviously, it is operated on the principle that the cylinder piston approaches the end of the stroke. An exhaust fluid that is forced to go through an adjustable needle valve, which is set to control the escaping fluid at the given rate. It is nothing but the maximum pressure that is being entering cannot be imagined in the dynamical position. So hence, indeed to cope up or withstand the pressure which is entering in at a maximum rate will be observed, and rest of them will be controlled by escaping the fluid at a given rate. And even this allows the deceleration characteristics to adjust the different loads. One thing it is that when the cylinder piston is actuated The fluid will be entering into the cylinder port and close the little check valve so that the entire piston area can be utilized to produce the forces in motion. Hence, this is the condition. When the stroke is retracted or load is being applied in this condition, hence the fluid which is having interconnectivity will be entering into this, and hence this check valve opposes the fluid, and there is no any doubt that the fluid will be entering into this particular channel which maintains the constant library is for this cushioning port. And here the throttle valve specifies or adjusts to a maximum pressure that can be withstood. And if at all that pressure deviates, then it leads to fall on that particular cushioning port. So, for example, the tension or opposing pressure maintained of 5 bar of pressure, and up to the 5 bar of pressure, there will not be any contraction, or in the case of this return stroke, to be falling directly this piston on that particular cushion port. And other than that, if it is existing, then the conditions will be acting simultaneously. This is the cushioning of cylinders. So, what is the operation of cylinder in the case of this cushioning? So, this is an exhaust flow passes freely out of the cylinder, and most probably this cushioning factors leads to the maximum absorbing of the pressure that has been allocated on that particular cushioning pad due to the dynamical loadings or uneven forces that are being acting on that particular piston. Mean to the cushioning pressure, how these uneven forces are being characterized in the shown pictorial representations. Here, directly falling on the cushioning port, and how these are being balanced. Just will be having a clear cut look over this. During the deceleration, extremely high pressure may be developed within the cylinder cushion. So obviously, other than the throttle conditions, if the pressure has been developed due to the uneven forces or conditions in the dynamical motion, simultaneously a maximum or high pressure that will be getting developed in the case of cylinder. This action of cushioning device is to set up a back pressure to decelerate the load. So indeed to cope up with other than the maximum conditions, other than the maximum conditions. So here it specifies other than the maximum conditions. So the retraction force need to be commenced on that particular load which is getting appeared or entering into the cushioning pad. Nothing but here back in the pictorial representation, the throttle conditions need to be increased and this cushioning port need to be getting energized towards the opposing characterizations of this return stroke, or else the uneven pressure which is entering should be opposed by this cushioning port. So how it is being considered? So what is the maximum speeds in cushioning cylinders are being occurred? So the maximum speed of cushion rod is limited to a rate of fluid flow into and out of the cylinder, and the ability of the cylinder to withstand the impact forces that occurs when the piston motion is arrested by the cylinder and plate. So for uncushioned cylinders, as per the experimental criteria, and having 8 meters per minute, the cushioning factors, maximum speeds maintained in the cushioning factors is 8 meters per minute. And for cushioned cylinders, that is nothing but already existing somewhat pressure containing or maintaining characterizations 12 meters per minute. For high speed or externally cushioned cylinders, 30 meters per minute. Coming to the point of this acceleration and deceleration of the cylindrical loads, we'll be calculating based upon the cylinders which are decelerated, and even the cushioning and cylinders are accelerated to produce this reduce cycle time of the operation by utilizing the following equations, that is the distance area calculations and distance calculations and velocity calculations, and nominally the initial velocity has been given, and this acceleration will be finding out, and based upon the time factor that velocity need will be found out, that is v plus u, v is equal to u plus at, and simultaneously v square minus u square is equal to 2as, and s is equal to ut plus half at square. So nominal calculations characterizations. So this is the movement that we have been seeing in the previous slide, that when the pump or pressurized fluid enters the condition, it will direct towards the forward movement while the fluid enters into the input port 1, and port 2 will retract back the fluid towards the reservoir, and vice versa. If the fluid enters into this particular channel, a retraction stroke will be commenced, and this pump will be connected towards this piston port number 2, and the port 1 will be drained back to the oil reservoir. Going to the point of these advantages and disadvantages in the case of these hydraulic actuators. Coming to the point of these advantages, it's having the large weight lifting capacity, high power to weight ratio, will be maintained only towards the moderate speeds because quick actions cannot be performed as it considered in the case of these pneumatic conditions. Oil is incompressible, hence, if one's position, joints can be locked to a stiff structure, and good servo control is achieved. And in the case of this hydraulic, it acts as a self lubricant, whereas in the pneumatic, we are being utilizing this lubrication section, filtration, lubrication, and regulation. Coming to the smooth operation will be possible without any noise creations, and better accuracy will be getting maintained. Coming to the point of disadvantages, these are very much expensive. Maintenance problems with seals causing the small leakages of pressurized fluid, and this leads to an decrement in the efficiency. And it's not suitable at the high speeds cycling, and hard to miniature because high pressure and flow rates are being taking place. We'll be having a glance of these pneumatic advantages and disadvantages. It is relatively expensive, it is input expensive, and quick actions can be performed. It can be used in and even our library work also for commencement of very much speedy in nature. No written line required, and suits for modern robotic designs. Only at particular limits to particular extents. Coming to the points of disadvantages, noise pollution from the exhaust, leakage of air can be concerned. Additionally, drying or filtering may be required. So these are the general disadvantages in the consideration of this hydraulic and pneumatic actuators. Furtherly, we will be proceeding the actuation elements and directional control valves in the next class. Thank you.